Welcome back to the LLM Wiki. This is episode 7, and the tone shifts here. For 6 episodes we built the case for the wiki, 4 pillars, real results, a genuinely new idea in the constraint oracle. Now we do the harder, more honest thing. We turn the same critical eye on the pattern itself and ask, where does it break? Because every result in this series came with a caveat, and those caveats are not footnotes, they are the research frontier. So this episode is a tour of the limits. The scale ceiling, the multi-agent mess, the reasoning gaps, and the uncomfortable truth about how much autonomy you can actually trust. If you remember one episode for what is still unsolved, make it this one. Start with the most fundamental limit of all, scale. The wiki pattern works beautifully when one maintainer covers one domain. Push past that, and something quietly goes wrong. We profiled the same health metrics on wikis of 6, 22, and 84 pages. At 22 pages, 2 things stayed in step: content trustworthiness at 0.77, structural health at 0.80. But at 84 pages they tore apart. Structure climbed to 0.93, while trustworthiness collapsed to 0.49. The 84-page wiki had grown to 43,000 characters of compiled prose against 40,000 of actual source, and a plain keyword search could trace only 23% of its sentences back to anything real. Content trust is not a thing you can simply grow. Why does scaling break it? 3 problems, none of them merely technical. First, schema governance. Once many people share a wiki, the schema itself has to evolve and migrate by agreement, and that is a social problem, not a coding one. Second, ontological commitment. As pages multiply, the definition of an entity drifts silently from page to page. Fixing that needs real class hierarchies and disjointness axioms, the kind of thing formal ontologies enforce and plain markdown simply cannot. And third, concurrent updates. When a language model edits a page and a human edits the same page, you have a 3-way merge problem with no clean solution. The wiki pattern, as proposed, assigns none of this to any mechanism at all. Now widen the lens to many agents sharing one wiki, and the cracks get sharper. The most immediate one is page ownership. A markdown file system has last write wins semantics: whoever saves second silently overwrites whoever saved first. So when 2 agents update the same page from different evidence, one agent's work just vanishes, with no record that a conflict ever happened. The provenance graph from episode 4 helps a little. Its dual-layer diff can at least notice that a silent overwrite occurred. But noticing is not resolving. Detecting that 2 agents disagreed tells you nothing about which of them was right, or how the disagreement should be settled. That second question is wide open. And some conflicts cannot be settled at all, because nobody is wrong. Picture a clinical agent maintaining a patient page through diagnostic reasoning, and an administrative agent maintaining the same record through billing codes. Their statements can be flatly incompatible under a single medical ontology, yet each is correct inside its own frame. The 2 views are simply incommensurable. The wiki has no way to mark this frame-relative conflict as different from a plain factual error. Doing it right means storing not just claims but their context: who wrote it, in what system, for what purpose. The natural architecture is federation. Every agent keeps a local wiki, and a protocol syncs them. But what actually resolves a conflict? An authority agent, a majority vote, evidence weight, a human reviewer. That policy is unspecified, and it should probably differ by domain. Step back to the big picture from episode 2, where the wiki was long-term semantic memory, sitting beside episodic and procedural memory. The trouble is, the interfaces between those tiers are barely specified. Between the wiki and fast vector retrieval, recall our graph retrieval study found no benefit from link structure at small scale, but that result is scale-dependent. At thousands of pages, exploiting hierarchy and confidence weights as a retrieval signal becomes a real, unsolved design question. Between episodic and semantic memory, we know how to promote experiences upward, but the reverse, rereading old logs through the wiki's current understanding, is unexplored. And procedural memory, the tool definitions and policies, does not fit Markdown at all. 3 interfaces, 3 open problems. Even when the right facts are all present, the wiki does not fix the depth of reasoning over them. Multi-hop reasoning fails in 3 distinct ways. The first is working memory overflow. A query that needs 5 or 6 pages at once exceeds what the model can hold coherently, because attention dilutes over long contexts and things get lost in the middle. The second is the verification gap. Producing a plausible inference chain is far easier than checking that it is valid, so a model can confidently confabulate the middle steps while correctly citing the ends. The third is compositional brittleness. Steps that are each valid alone fall apart when chained, because the intermediate conclusions quietly stop referring to the same things. Plausible is simply not the same as correct. So what would actually fix this? Chain of thought helps with overflow. It externalizes the steps, but it does nothing for the verification gap or the brittleness. The principled answer is the neurosymbolic layer from episode 5, let Prolog or ASP verify each intermediate step. But that only works for knowledge already compiled into formal logic, and we saw how small that fraction is. A satisfying architecture would do 4 things: decompose a hard query into pieces small enough to hold, track each intermediate conclusion with a confidence that decays as the chain grows, verify formally where the logic exists, and fall back gracefully to an honest "I am not sure" instead of a confident fabrication. None of those is hard to state. Building them without wrecking the wiki's simplicity is the hard part. The path to formalizing rules also looks completely different from one domain to the next. In education, the rules are pedagogical prerequisites, coverage, stable and clear enough that a course instructor maintains the prologue directly, no logic programming expert required. The barrier is low. Healthcare is harder. Clinical guidelines come from bodies like the Diabetes Association on their own schedules, their authority is itself graded from A through D, and formalizing them needs both logic skill and deep domain context. Law is harder still. Legal reasoning is non-monotonic. A later statute overrides an earlier one, which calls for ASP rather than Prolog, and that expertise is scarce. And government is the trickiest of all, because policy is often deliberately ambiguous, so you formalize only the settled parts and leave the contested ones flagged as conflicts, not frozen into one interpretation. Which brings us to the most uncomfortable limit of the whole series: how much can you actually let the wiki run itself? Look back at the evidence. The routing feedback loop, trained on its own mistakes, got worse. The contradiction detector flagged 10 pairs and only 2 were real. Drift accumulated silently. Every single place we hoped for full autonomy, the data pushed back. So the honest operating regime is not a self-maintaining wiki. It is human-assisted automation. The model does the heavy labor, and a person reviews the changes, validates the contradictions, and sets the compilation schedule. That is a far lighter load than hand-curating a knowledge base, but it is not zero. And it raises a governance question with no neat answer. In an institution, who exactly is qualified to be that reviewer? There is one more limit, subtle but corrosive. The wiki is written by a language model, so it inherits the model's writing tics. Overhedging, it should be noted, it is important to understand. Artificial parallel structure. A habit of summarizing and enumerating that flattens real distinctions. On its own that is just bad prose, but it interacts with drift in a dangerous way. If the compiler keeps trading precise, qualified language for smooth general summaries, the wiki slides toward a bland consensus view, the very same mechanism that drove causal drift 4.7 times higher in our archaeology study. The mitigations are partial, structured schemas that force fields like evidence level and counter-evidence, rule layers that enforce hard distinctions, and lint that checks individual claims, not just topics. None of them is a cure. So let us put the whole map on one screen. The scale ceiling, trust diverges from structure as a wiki grows. The multi-agent problem, silent overwrites, and conflicts where nobody is wrong. The memory interfaces, 3 tiers, 3 unspecified boundaries. The reasoning gaps, overflow, the verification gap, compositional brittleness. The vertical domain divide, easy in education, hard in law and government. The writing artifacts that quietly smooth away nuance. And running underneath all of them, the autonomy ceiling, this pattern needs a human in the loop. 6 families of limits. Notice that they are not bugs to patch, they are the open shape of the problem itself. And here is the stance the whole series tries to hold. Every result we have shown you, the good and the bad, came from small to medium wikis, several of them built on semi-synthetic data. We genuinely do not know how these findings behave at institutional scale, with more capable models, in real deployments. The problems that only appear at scale, ontological governance, concurrent editing, multi-agent trust, we have barely touched empirically. So treat the positive results as encouraging signals, not settled facts, and treat these limits as the honest edge of current knowledge. That humility is not a weakness of the work. It is the point of it. But a list of limits is not where a good research program stops, it is where it starts. Everything in this episode was architectural and conceptual, questions about how systems should be designed. The next episode does something different. It turns these open problems into concrete experiments you could actually run: error propagation models, continual update strategies, security threats, and the standardized benchmarks the whole field is missing. We have spent this episode being honest about what we do not know. Next time, we lay out exactly how to go and find out. The pattern's edges, turned into an agenda. Episode 8, A Research Agenda. See you there.